substitution in terms of hyperbolic function. Substitution in terms of hyperbolic functions. Now hyperbolic functions. The trigonometric hyperbolic function. That is t equal to, let here, cos hyperbolic theta. Okay, so differentiating with respect to theta. Differentiating with respect to theta, we get this is we get therefore or we obtain this is dt. Okay, this is dt upon d theta equal to sine hyperbolic theta, or we find that dt equal to sine hyperbolic theta into d theta. Okay, so this let me convert further. This is 1.2 minus integration. In under the cos hyperbolic square, cos hyperbolic square theta minus 1 into sine hyperbolic theta out of sine hyperbolic this will be 1.2. Again, sine hyperbolic square theta inside the square root will come out as sine hyperbolic theta into sine hyperbolic theta is always here into d theta into 1.2 sine hyperbolic square theta d theta. Now since we know that formula, the 2 sine hyperbolic square theta is going to cos hyperbolic 2 theta minus 1 upon 2 sine hyperbolic theta. Let me substitute here. So this is 1.2 already. Sine hyperbolic theta means cos hyperbolic theta minus 1 upon 2. This 1.2 has come out. It will be 1.4. Sine of integration, let me separate them. This cos hyperbolic theta minus d theta. Sine of integration. This is also d theta. This is cos hyperbolic theta into d theta. We are separating them. So this will be clear. It is cos hyperbolic theta d theta minus sine of integration d theta. This 1.2 are taken out. Let me write it here. So t was substituted here. Okay, and theta was t was the cos hyperbolic theta. First we have to substitute t cos of theta, then theta cos of theta. Okay, this was there because t was x square. Cos of theta is communicated with t and t to x square. Okay, so reverse case we have from here. This is 1.4. Cos of theta is, let me write sine hyperbolic theta upon 2. 2 will be divided. And after integration, we divide by the coefficient of theta, so variable there. In this case, variable of theta, sorry, coefficient of theta, but in case of x, coefficient of x. Yeah. If we are integrating with respect to x here, then dx it was there. We did t, then dt. So with respect to t or dt, that depends. Whatever coefficient of that variable is there, that will divide by integrals after the integration. Okay, by the coefficient of that. So this is this one. So now this minus theta. Okay, so can be written again 1.4. This is 2 sine hyperbolic theta into cos hyperbolic theta. We know this formula. Integration of minus theta is cos hyperbolic inverse t, because we assumed as t equal to cos of theta, theta equal to cos hyperbolic inverse t. Okay, now let me substitute the values for that. So answer was the answer, but it was 1.4. Okay, I remember that. So this is 1.4. The same question will be here. It minus hyperbolic cos hyperbolic t. This was 1.4. Let me write it first. Minus cos hyperbolic inverse t. T means x square. Write it down. Minus sine cos hyperbolic theta theta is p. Under root p square minus 1. P square minus 1. Now substitute the value of p. P is x square. One is minus cos hyperbolic inverse. P means x square minus sine, this is x square under root x4 minus 1. Okay, this is answer. Or if I further substitute value of cos hyperbolic inverse x, that will substitute that also. So 1.4, let me first write, this is plus sign. Sorry, plus sign. This is minus sign. So 1.4, let me write this x square is positive, so let me write that first, x4 minus 1 minus sign. Now cos hyperbolic inverse is log of, as we know, either this write like this or write in logarithm. Okay, this is plus constant answer, or this may be the answer. This is x square, this value, okay, plus sign under root, the same value x4 minus 1 will come out. This is x square plus under root x4 minus 1. This is in terms of log the value of cos hyperbolic inverse. Cos hyperbolic inverse x square. Factoring in that way, that was initially we did plus constant. Whether this is the answer or this. Now this is question number 17 we have done. Now let me take the 18th question. Now question number 18. What does it say? Question number 18. Let us talk about it. Sign of integration, this is cos x under root 4 minus sine square x dx. Now in this case, in place of sine square x, sine x, we have to substitute some other variable. Let me take, let sine x equal to 2 into t, so that this 4 can be taken out. So that will be there. Now let me further differentiate with respect to t. Differentiating it with respect to t, we get, this is cos x differentiation positive into dx. Why? Because dx upon dt will be there, into dx equal to twice dt, this side twice dt. Okay, so t will be 1, 2 into 1, that means 2 only, but dt will go from this side to that side, so 2 dt. Cos dx, okay, equal to twice dt. Let me write it as under root 4 minus sine square x into cos x into dx in proper way, so that we can substitute this value directly to dt. This is twice dt means 2 taken out. This is under root 4 minus 4t square into dt. So this is twice under root 2, from this also will come out. This 2 further sign of integration within bracket 1 minus t square. Now into dt. Now this is simple substitution. Means simple means sine theta we can substitute here. For square root, out of square root we have to take this value out. Otherwise we cannot solve it. So for the t, now in this case it is 1 minus t square. Okay, it is not it is not 1 plus t square, so hyperbolic function cannot be taken. Hyperbolic function may be taken, maybe second hyperbolic theta we can take, but that's not required. Let me take t first. Okay, t, sorry, sin theta only. Let t equal to sin theta here. Okay, so therefore differentiating with respect to theta, differentiating with respect to theta, we get, it will be dt upon d theta, dt upon d theta equal to cos theta. That means dt is equal to cos theta into d theta. Substituting this value in place of dt and in place of t, it will be 4 sine of integration under root 1 minus sine square theta into cos theta d theta. Be 4 into, now out of under root be cos square theta, then square root is also there, be cos theta out of this. Cos theta d theta. The same value. 4 into sine of integration cos square theta d theta. Now cos square theta we know that this is 1 plus cos 2 theta upon 2. Since 2 cos square theta equal to 1 plus cos 2 theta. Simple. Therefore this can be substituted. Cos square theta equal to 2 upon 2 or cos square theta equal to 1 plus cos 2 theta. Okay, upon 2. Let me substitute this value. Therefore sine of integration 1 plus cos 2 theta upon 2 into d theta. So 2, if I take out, it will be 2. Remaining 2 only, 4 upon 2 means 2 only. Now let me integrate them. First is d theta integration plus sine of integration cos 2 theta d theta. So this simple integration, not hyperbolic. Let me integrate them. Let me integrate them here. Okay, so this will be twice sine of integration. This is theta only. First term plus it is sine 2 theta negative. Sorry, but it is integration to be positive and not negative. I was thinking just like hyperbolic function, so but hyperbolic also is positive. This is sine hyperbolic. Integration of cos hyperbolic theta is positive. This sine hyperbolic, sorry, sine 2 theta. Okay, upon 2. Constant is there. It is why I am writing integration sign bracket only now. So integration is done. This is theta, d theta is theta, 1 integration of 1 theta plus cos 2 theta is sine 2 theta upon 2. It's integration, simple. Okay, this plus constant of integration we can write here. Now this is twice theta. From this one, it is sine inverse t only plus 2 sine theta into cos theta upon 2 plus constant of integration. Now since by this is again sine 2 theta, we know that it is 2 sine theta into cos theta. In hyperbolic also the same formula is applied. Okay, so this is t we have converted into theta. Now finally, well, still theta is to be converted into t. So that was we consider sine theta in place of t. To cancel out, it is twice sine inverse t. T I'll substitute that t equal to sine x upon or 1.2 to sine x plus this is sine theta. Sine theta means p here. We substitute t equal to sine theta in the last one. Okay, second substitution. So this is t under root of 1 minus t square. Cos theta means 1 minus sine square theta under root into plus constant of integration. Now t we have to substitute as sine inverse 1.2 sine inverse x. It will be t equal to, therefore twice it will be sine inverse 1.2 sine x. For 1.2 will come here. It will be t equal to that value plus t is again sine x upon x and sine x upon 2 t first. And it will be inside 4 minus sine square, because upon 4 will be there. It will be sine square upon 4. LCM taking 4, that means 4 minus sine square x upon 2 out of the square root. 2 to 4. The constant of integration. So this is this answer twice into sine inverse 1.2 sine x. Okay, this is plus sine 1.4 sine x upon 4 under root 4 minus sine square x. Okay, that was this value, last value. Plus constant of integration we can write. This is the answer. Okay, no other answer here. Sine inverse x upon 1 upon x. We have written here. So this is your final answer. Now let us take next question. So this is simple transformation, I mean simple substitution, not hyperbolic function, because it was 1 minus t square, right? So question number 18 we have done. Question number 18, okay. Now let me take 19th question. Question number 19. The question number 19 is this 19th question, let me take. And question number 19 is what? Okay, this is son of 28 secant x tan x. Okay, secant x tan x, then under root this second square x plus 1. Okay, dx. Now again in this case it's not trigonometric type, but finally it will be, sorry, hyperbolic function it will be, but before that we have to substitute sec x, let's secant x equal to t. Okay, so this will be different with respect to t, differentiating with respect to t, that we write directly t, we get different with respect to t, differentiating it with respect to t, we get what is second square x. It is secant x into tan x into dx equal to dt. Let me direct, right? It will be dx upon t here, and it will be 1 dx, take dt to that side. This is this value. Okay, so in place of this, okay, let me write it the proper manner. This is secant square x plus 1 into secant x into tan x into dx. Now it can be substituted. So this is under root t square plus 1 into dt. This whole value is dt. Now this we have obtained. What is this? Under root t square plus 1. This we have done as 14th, I think, or which one? Okay, it was just like t. Okay, there was double substitution. Here also we have substituted double, but in this case, this we have obtained. In this case, what is the final answer of this? This is sin hyperbolic or something. Okay, so that will be, again, let me substitute here t equal to sin hyperbolic theta. Theta. Okay, so that will be, again, will be out, that will be cos hyperbolic theta. Cos of theta is positive. That will be 1 plus, that means theta plus sin 2 theta. Okay, upon 2 will come out. Okay, so 1.2 will be there. It will be, let me write here, answer 1.2. Okay, so we have to substitute sin inverse. So it will be sin hyperbolic inverse. Theta means t square. That means t means sin x. Sin hyperbolic inverse sin x. So it's, sorry, secant x. Sin hyperbolic inverse secant x. It will be in this way. Plus first value will be sin hyperbolic theta. Okay, sin hyperbolic x into, sorry, sin hyperbolic theta into cos hyperbolic theta, and in place of t, sin hyperbolic t and cos hyperbolic t, and that t we have to substitute finally t or theta. Theta, sin theta will be t. Okay, and t, then t to substitute as second square, that will be secant x into secant x under root, okay, secant square x plus 1. It's the same thing, secant square x plus 1. This kind of answer will be there. Okay, now if I do this in a proper manner, let me take substitute as sin hyperbolic inverse theta in this case. Let t equal to further substitution. This is the answer here. Okay, it may be plus or it is positive, because in case cos 2 theta, it will be cos hyperbolic 2 theta plus 1. It will be both plus. It will be theta plus sin 2 theta. Sin 2 theta means 2 sin theta cos theta, and we have taken t as sin theta, and therefore that will be, and t is secant x finally. So secant x under root secant square x plus 1, the same value which is here, that will be there. This is the final answer, and this can be substituted as log of this secant x plus under root secant square plus 1. So that is for the answer. Now let me either write directly if there is short question, or I mean marks are very lesser of question is of lesser value or lesser marks, then we can just write directly answer this. And if this is to be done as further substitution, okay, then take it lengthy method. So that will be let t equal to sine hyperbolic theta, different with respect to theta here, differentiating with respect to theta, we get, okay, so what we get, dt upon d theta, or d theta will be taken by side. This is cos hyperbolic theta into d theta. That we substitute here, it will be under root 1 plus sine hyperbolic square theta into cos hyperbolic theta d theta. It is nothing but out of this will be cos hyperbolic theta. That means cos hyperbolic square theta d theta will be, because this is already there. From this square root we will get cos hyperbolic theta. That means square theta. Now it can be substituted as 1 plus cos hyperbolic 2 theta upon this I was talking. This is 1.2 we have taken out. Now integration of this is d theta. I'm sorry, this is d theta. So d theta plus cos hyperbolic theta, sorry, 1.2 is further from, sorry, this 1.2 we have taken. This is cos hyperbolic theta integration hyperbolic 2 theta d theta. This I was talking about. This is 1.2 with theta plus this is sine hyperbolic 2 theta upon 2 integration of this. This will be 1.2, but the theta is sine hyperbolic inverse t, hyperbolic inverse t, where this is nothing but 2 sine hyperbolic theta into cos hyperbolic theta upon 2 into cancel out. Substituting value of sine hyperbolic theta, which is t, and under root cos hyperbolic theta means 1 plus sine square, that means 1 plus t square, and t is secant x. We can substitute that value. This is the same value we have obtained here. In place of t we have to substitute secant x here. This is sine hyperbolic inverse secant x plus secant x. Okay, because sine hyperbolic theta is t. T is secant x. In this place, secant x under root secant square x minus 1. The same value will be there. So this is the answer. The same answer. This is the answer. This is the final answer. We have substituted now value of t. This secant x here, and here sine hyperbolic theta is t. We have taken t under root t square plus 1 cos hyperbolic theta is. Okay, this is sine hyperbolic inverse t. That is this value. This secant x t. This is this one. Okay, the same answer is obtained. This is what directly, if we have to do that, put the answer then, or we can take that substitution, next substitution also. That is how process can be repeated. Now let me take next question. 19th we have done, 20th one. Question number 20th. 20th question. This is sum of integration x plus 1 under root x square plus 1 into dx. Now it can be taken as x under root x square plus 1 into dx plus sum of integration, okay, 1 into this, that means under root x square plus 1 dx. This is what we have obtained. Now this is just we have integrated. It will be what? X equal to sine hyperbolic theta, that means theta plus sine 2 theta, that means 2 sine theta cos theta. The same thing as we just did, that will be there, because cos 2 theta means cos 2 theta plus 1. That will be plus this plus sign. Here we have to substitute that t equal to, in this first one, x square plus t. Let me do the first part. Second part is solving. This is, sorry, first part. This is second part. I'm doing the first part first. So in the first part, let x square plus 1 equal to t. Or we can take t square. Just take t, no problem. It will be t. Therefore, twice x into dx equal to dt. Differentiating with respect to t here. It will be 1 here. It will be twice x into dx upon dt. Dt can be taken, this 1 is 0. Therefore, x dx equal to dt upon 2. Substituting this value here, we get, okay, let me first write it as x square plus 1 into x dx. That can be now substituted. So x square plus 1 is t, it is under root t. Okay, this is dt upon t, 1.2 can be taken out into dt. So its integration will be 1.2 t raised power half plus 1 upon half plus 1. This is integration. It will be 3 by 2 here, 2 upon 3, that means 1.3 only. And t raised power 3 by 2. This is 3 by 2, 2 upon 3. So 2 to cancel out, 1.3 only will be there. This is 1.3 t. T we assume as x square plus 1 whole power 3 by 2. This is the first part. Okay, the second part we know this. This is equal to plus sign 1.2 we can take out. So that will be theta means sine hyperbolic inverse theta. Sine hyperbolic inverse theta means x square. Here we will have only x because no x square, only x plus under root x under root x square plus 1. This is the second part because we have to substitute here x equal to this x equal to something means sine hyperbolic theta. It will be sine hyperbolic theta into cos hyperbolic theta. Cos hyperbolic theta is this value and sine hyperbolic theta is x. This is the answer here of second part. So this is first part and second part is this. So answer, final answer will be, if we write the final answer, the first part plus second part, it will be 1.3 the first part x square plus 1 whole power 3 by 2. The second part is plus this 1.2 into sine hyperbolic inverse x plus x under root x square plus 1. The same thing we have to repeat here. X square plus 1 we have to assume x as sine hyperbolic theta. Okay, because we know that 1 plus sine hyperbolic theta is equal to sine hyperbolic square theta equal to cos hyperbolic square theta. That is okay, can be converted. So in this way we have to do the same thing. This is the final answer because in this case only x is there. This is the answer. Okay, substitution in this case, let take x equal to sine hyperbolic theta, sine hyperbolic theta, x equal to sine hyperbolic t, dt. Then further t can be converted as sine hyperbolic inverse x. Okay, so this is your final answer. Question number 20 is to be done here. Okay, now let me take 21st question. Now question number 21st. What does it say? Question number 21st. Okay. Question number 21st. Okay, is that x square plus 1 upon under root x square plus 3 dx. Now, there is no need of making it perfect square because x is not there. We can separate them into two parts. First is x square upon, or let me do it in another way. The first part can be added something. Here it is x square plus, let me write 3 first, 3 and minus 2. We change it is plus 1 here. Now it can be divided by x square plus 3 into dx. So the first part is x square plus 3 upon under root x square plus 3 into dx minus sign 2 let me take out is dx upon under root x square plus 3. So this is same thing here in the denominator we will get x square plus 3 into dx. There are two parts here, two types of questions are included here. This is of integration type. This is dx upon under root. This is x square plus under root 3 whole square. Okay. This this is x square plus a square. That means sin hyperbolic inverse x upon under root this value. And this is we have just done. This is also can be written as x square plus under root 3 whole square into dx minus 2 same thing upon under root x square plus under root 3 whole square. Okay, so this is x square plus a square type. So in case of sin hyperbolic inverse, we do not write 1 upon a, no, but sin hyperbolic inverse x upon a, that will be there. In this case, you see the plus sign we just did, that was 1.2 out, is bracketed with theta plus, that means sin hyperbolic inverse under root x upon under root 3. Okay, plus, because this is sin hyperbolic theta into cos hyperbolic theta, sin hyperbolic theta will be x upon root 3 into under root the same thing with x square plus root 3 plus 3 only inside. So inside value will be x upon 3 of x square. Okay, so this is what you will get the answer of the first part. Second part is nothing but this is 2 sin hyperbolic inverse x upon root 3. Okay, this is plus constant of integration. Now sin hyperbolic inverse x upon root 3 is this 1.2 this time, and these two can be added or subtracted. Okay, so that is minus 1 upon minus 3 by 2 it will be. Why it is minus 2 to the 4? Because this is same repeated one. Okay, so that can be further summarized. This is 1.2, this is minus 2, that is minus 3 by 2 will be left over. Minus 3 by 2 into sin hyperbolic inverse x upon root 3 plus this value is there 1.2, that means x upon root 3 under root x square plus 3. Okay, plus constant of integration. This is answer here. Adding them those two. So directly we can substitute this question, or here the same thing will be repeated. This is under root 3 x square plus a square type. Okay, so in this way the sin hyperbolic inverse this value. Alright, or we can after substitution we can do this, because in both the cases we have to substitute sin hyperbolic theta x equal to sin hyperbolic theta, or under root 3 sin hyperbolic theta we have to substitute here, so that